I'm preparing an online version of this class, not 100% online, but partially online. So I'm trying to figure out what to record and what to put up for videos content. All right, so let's go to our workspace. Oops, that was not smart. So this is the, I'll just do the work in here. There it is. All right, so here's the problem. Detecting prime numbers with functions. So implement a function that takes an integer value and returns true if the integer is a prime number and false otherwise. The function should have the following signature. So this is what the function looks like. The name is prime, and it takes an integer n and returns true or false. That means it returns a Boolean value. That's the data type. Use an assert statement. Use an assert statement inside the function to check the precondition that n is greater than 1. So I guess it's meaningless to ask the question of whether an integer equal to 1 or less than 1 is prime. So that would be not part of the definition of prime number. So it would be a meaningless question, I believe. So when the function is called, n should be 2 or larger. So we just use an assert statement in there just to check that. Include the function in a console program that calls the isPrime function with a range of values that tests several common cases as well as the boundary cases. Use an assert statement for each test case. For example, the following tests that the function returns false for the value 100. So 100 is not prime. So if we pass 100 to the isPrime function, the function should return false. It's not prime. So we put that inside of an assert statement. This expression right here, this is where we're invoking the function. We invoke a function. You can think of it as a function being replaced by its return value. So this will be replaced by the Boolean value false, assuming that we implement isPrime correctly. And so we compare false on the left-hand side with false on the right-hand side. So that comparison is true. That's a truthful, that comparison is true as opposed to false. So when you pass true to assert just does nothing. Just lets the next statement execute. But if isPrime was implemented incorrectly, isPrime would return true for 100. And then true would not be equal to false, and the assert statement would then terminate the program with an error message. So this is a form of one way to do automated testing. And in real automated testing, in the industry, you don't use assert statements. You use test cases, and there are frameworks that developers use to do test cases. But the assert function is important to learn about, so that's why I'm using it for this purpose. There's a header for this assert. You need to include that in the program to use the assert function. All right, so once again, we need to implement this function, isPrime, and test it with assertions. So if we're going to call this function, it needs to be known before we use it. So if we define it here, we'll define it with a stub. We'll just return true always. That's called a stub. We didn't fully implement the function yet. Yeah.
What's bool or
Bool is a data type like int or double or string. It's a type of data. But the data values can only be, there's only two data values, true and false. So it's a variable. If you declare a variable to be of type bool, you can only store true in the variable or false in the variable. The variable doesn't store a number, for instance. I mean, actually it does internally, it's a number. All right, so that's how you declare a function or define a function. Once again, we're just implementing it first as a stub. It's not the full implementation yet. We just want to get the test code written first. And then here's the main function, and then we'll do some tests, and then we'll print all tests passed. So if an assert statement fails, we won't test all tests passed. We won't print all tests passed. We'll print an error message. Let's just see how this builds and runs. All tests pass. So some tests. Well, let's do the test that's shown, that was used as an example in the instructions. We'll assert that calling is prime with 100 returns true. Oh, sorry, false, right? 100 is not prime, so that should return false. Now, we've implemented the function as a stub, so we're going to have a failed assertion. And that's what we intend to do at this point in the development. We intend, predict that the assertion will fail. Up. What's the problem? Assert was not declared in the scope. We need to, there's a header file that defines assert. It's called C-assert. Assert was not declared in this scope, right? So now it is declared in this scope. And it works. So what's going to happen when we run it? It's going to say all tests passed? No. We're going to get a failure in line 11. There it is. There's the 11 right there, line 11. Assertion is prime 100 equals false, failed. And then it says aborted. So it terminates the program right there. Doesn't print, doesn't get to line 13. And we'll need, before we implement the function, let's go ahead and create some more test cases. The other problem, I asked for 8 test cases. Let's go ahead and use 8 test cases. So it's important when you do testing to test boundary cases. So 2 is the smallest prime number. So let's try 2. Oh, by the way, that should be true. And 3 is, close to 2, so that's not exactly boundary case, but almost. And then 4 is the first non-prime number. So that should be false. And 5 is the first prime number after the first non-prime number. And then we just keep going here. 27 is an important case to test, I have discovered. That's false. Right? That's 3 cubed. And some other ones, 100 and 101. Is that prime? So I don't even know, right? I don't think 101 is divisible by anything. Let's leave it like this. Let's make this 105 is not prime, 100 is not prime, and 42. Some people like that number. And there we go. Maybe we need a large prime number in there. Like 29, I believe that's prime, right? That should be true. That's prime. All right, so just check that it builds. Of course, it's going to fail, and that's what we expected. It passes on these two because, well, we're returning true, but it fails there. So now it's just a matter of implementing the function is prime. And to check to see if a number is prime, the algorithm that we're using is that we're just going to try to divide n by 2, then by 3, then by 4, and so on. If we find that any of those numbers evenly divides into n, then we know in that moment, when we discover that number, that n is not prime. If we try all the numbers and none of them divide evenly into n, then we can conclude that n is prime. We'll use a loop for that. We'll start at 2. That's where we start from. We'll divide by 2, then we'll divide by 3, and so on. And this I needs to be less than n itself, because we don't want to divide n by n. That will always work, right? And then increment I. And we check if n mod I is 0. So n mod I, that means divide n by I and get the remainder. What's the remainder after dividing n by I? Well, if the remainder is 0, it means that I evenly divides n. In that case, we're going to return false. We know on the spot right there in that moment that n cannot be prime because we found a divisor I. So we're going to return from the function false. Now this breaks out of the loop. This return statement, we leave the function, we return back to, say here, for instance. So we'll branch back to here. So when we call is prime here with 4, when we call is prime with 4, then 4 will come in through n here. And then we're going to enter into this loop. We'll start with I equal 2. We're going to go 4 mod 2. 4 mod 2 is 0. So then we return false. That means this function here evaluates to false. And then once the system evaluates that call to false, it has the value of the left-hand side of this comparison. And it compares it, of course, to the right-hand side. We've got false equals false. That's a true statement. False does equal false. And so the assertion doesn't do anything, just quietly term finishes. And then the next statement in line 17 runs. Now, if we finish this loop and we never return false, it means we never find a value I that evenly divides into n. No value divides into n. So n will be something like 7. Right? And you're trying to divide it by 2, 3, 4, 5, and 6. None of those numbers divides into 7 evenly. And so when you exit the loop, you know that you didn't find a divisor, so you can return true. N is prime. So we're going to test this with this automated test code. So we're not going to do visual inspection. Well, we will. We just wanted to see it say all tests passed. That's the only visual inspection we need to do to determine that the function is written correctly. So we have, in that sense, we have automated test code. All tests passed. There it is. Now, if we had done this wrong, you know, like if we had started from, you know, if we had done something like this, you know, if n mod 2 is 0, okay, I've seen that before. That just means it's even. That means if n mod 2 is 0, that means that n is evenly divisible by 2. That means it's even. But what about something like 27? 27 is not divisible by 2, but it's divisible by 3. So it's 27 is not prime. So this will give us a false solution. And let's watch the test code catch that. And we want good test code. See, is prime 27 equals false, that assertion failed. That's because we haven't correctly implemented this function. Any questions on this one? Yeah.
So on line 6, you said Boolean was the number type, but is prime is not the name of the Boolean variable, right? That's a function.
Yeah, that's a function. Yeah.
And then
I think last time did I use is prime as a variable name? Well, I have in my other course actually.
so then what is, or you're defining n as the integer.
N is the integer that's being passed in as an argument. So like 4 here, that n becomes 4 when this invocation runs. So when this invocation runs, n becomes 5.
And so when you put that integer in the prime function, it can only produce a Boolean value. Is that what line 6
Yeah,
says?
it will only produce a Boolean value because it only produces what we return. So we're only returning true and false. You know, if we said return hello, you know, that's not a Boolean value, right?
So, and I haven't used return yet. I don't know why, but I haven't. So what is return?
Well, the return is that when you have this function, that's called a function invocation. You give the name of the function, parentheses, and you put in the arguments, the data that you want to pass to the function, like the number 4 in this case. And the function executes and it you know, churns and does its work. And then we say the function returns. But another way to think of it is that the function, the expression that I've highlighted right here, is replaced by the value that the function returns. So this would be replaced by false. That's it. So when we call the function evaluates to false or true, as the case may be.
Okay. And then the assert function is the program confirming that statement, and if it confirms, it doesn't necessarily need to print anything out, but if it isn't able to confirm, then the program fails.
Yeah, I mean here, if what the assert statement does is this. It looks at the, you know, it evaluates, the first thing is that what I've highlighted right there, that expression, it's an expression, the left-hand side equals the right-hand side. That expression is either true or false. If in this case, if is prime 3 were to return false, this expression would evaluate to false because we would have false on the left-hand side, the comparison operator, and true on the right-hand side. The false equals true, so that would be a false statement. Got it? Okay. If you pass false to assert, assert will terminate the program and print a message like this. Actually, what it does, it has access to the code that's in there and can print the actual code that appears within those parentheses. It can do that because assert is not a normal function. It's called a macro. I didn't want to get into that today, but it's not a function that we would implement using this mechanism up here. Assert, of course, assert comes with the language. It's defined with the C++ language, but something called a pre-processing macro. It's done at a stage in the compilation before other stuff. But once again, I don't want to get into that detail. You can just look at this as a function that if you pass something into it that evaluates to false, it will terminate the program with a helpful error message. Is that too much talking for an answer there? Make it. I talk too much. Yeah.
Okay, so I understand how the for loop mathematically can decide whether or not a number is prime.
Yeah.
But if you've already got a prime function, then why do you need the mathematical equation in the for loop to determine if it's prime?
Like in here? Like
Yeah,
this?
Dividing or using the modulo operator will tell you whether or not the number is divisible by anything, right?
Yeah, that's what we need it for. Yeah.
But then what is the prime function doing?
Well, this is part of the prime function. These are the instructions that comprise the prime function. This is called the implementation of the function. When you invoke the function, you execute two instructions in two statements. The first statement is the for statement, and the second statement that executes is the return statement. Now, this for statement that executes has a substatement in there. It's an if statement. Oh, and the if statement has a substatement within itself as well, which is this return false. That's a substatement within the if statement. So these statements, these are commands to the computer to do something. And this function, just by declaring the function is prime, isn't going to make it return true or false when a prime number is passed into it. We have to define the activity, we have to define the calculations that are performed to make that determination. That's what the for loop is all about. This defines the calculations that make the determination of whether n is prime or not. When you call the function, when you invoke the function, see right here, look at this. You're right there, okay? Now this expression here, this is a statement. I've highlighted a statement. Statements usually end with a semicolon. Now the statement runs, it doesn't just run it once. It has steps inside of it. One thing happens after another. The first thing that happens is that the is prime function is called with the value 4. And that execution, you can think of it as the computer of having like an attention. You know, like you have an attention. You're watching a television, right? And then you change the attention. The doorbell rings, and your attention goes to the door, right? You're like, I wonder who that is. Then you stand up, and then you walk there. Your attention is changing onto different things. So you can think of the computer as having attention, and it's executing something. It doesn't do everything at once. It does one thing after another. So we say, like when your attention goes from the television to the door, your execution is being transferred from one point to another. So here, when I've highlighted this is prime 4, that's an invocation, right? That's what we call. And now what happens is that the attention of the system moves to this function and then starts doing the commands that are listed in the function. And then when it's finished doing the commands in the function, then it returns back to where it came from. It returns back to here. Now when it returns back here, it comes back as a number. As a bool. It comes back as a true or false value. Well, why do we know that? Because we declared the function up here as bool. So we're telling the compiler that when we return from the function, that we're going to send back a true or false value. And you can use it, where to replace the expression where we had called the function. Yeah.
So why don't we use void or double in replacement of bool?
Why don't we use like double here?
Or void, yeah.
Or void? Well, void means we're not returning anything, but we're returning true. Now we're telling the compiler is prime returns nothing. But that would make this expression meaningless. We can't have nothing on the left-hand side. We have to have something. Does that make sense? Okay. And we don't want to declare it as double because we're not returning a double. We're not returning, 2.3 or whatever. We're returning true or false. So the data type that we're returning is a bool. We tell the compiler. Now the compiler's job is to generate machine instructions that control the CPU. Sorry about that. So these instructions are not running directly on the CPU. We need the compiler to generate what are called machine instructions, which can be loaded into the CPU, and the CPU will run through those instructions. By default, sequentially, but then you'll hit an instruction like a branch or a loop, and then you get non-sequential execution at that point. But that's for another course to look at that. So you got to practice this. Don't just read your notes. You need to do programming. So go into Cloud9 and create files and do experiments and master this. You got to do it. You have to do it. You can't just read about it. You can't just study your notes. It won't work. Yeah. All right. How about the next one? I think we finished with this, didn't we? Ready for this one? Back there?
No, we just did. I still have a problem with it. I don't.
What problem?
It doesn't show me like the number is prime, like 27 is prime or 5 is.
On your system?
Should I like put?
What's your work? Should we look at your workspace? Up here?
Yes.
Oh, hold on there. Let me go.
I probably missed a couple of steps, but
So, what's your ID? Your Cloud9 ID. Just spell it out to me, the first couple of letters. What's the-
I don't remember
What's the first letter in your ID?
Oh,
A, H,
M,
M. That one? M, A, you said? That one.
that one.
All right. Well, you got a lot of files open. Do you want all these open?
We're on exercise.
I'm going to be
right?
criticizing you now. That's the cost to have me do your homework for you. All right. I got to keep this clean, okay? Clean it up. You don't need all these files open. I got to tell you, it's confusing to have all those files open.
I was just like referencing from.
There we go.
Right.
So that's your cursor right there, see? That's you. So let's take a look, okay? And look at all this junk down here, see? What is all this? See, you got too much junk running here. You don't need this. You should take all this out. And see, you're hitting the run button, right? And I highly, strongly recommend that people don't hit the run button here. And the reason is you're going to be tested on the command line. You've got to practice the command line. So don't use the run button. This is the command line right here. Now, you need to create folders. You have to put this in a folder. All right. Do you know the command to make a folder?
Make there.
mkdir. Yeah. So you have to do these Unix commands. These are going to be on exam. And also in your courses next quarter, you've got to know this stuff. All right? So if you know it this quarter, you have to know it next quarter. And many of you will need to know these commands to do your jobs. These are, this is not like some trivial stuff that you can forget about, after the class is over. Now, for some of you, you can, of course. But many of you, you've got to live with these on a daily basis.
The commands are shared between other systems?
Huh?
Are the command lines shared between other systems? Like the,
Yeah. This command, mkdir, is common to Windows, Mac, and Linux, and all Unix systems. This command, rm, is only on Unix-style systems, like Linux and Mac, but not on Windows. Windows has another command for deleting a folder or a file. But these are Unix commands. All right, so Mac and Linux, those systems they work on. A CD, that's also a Windows command too. So some of them are as Windows commands, but Windows has different, like copy, Windows will have different. They'll spell it out COPY, or Xcopy, they use that one.
But they're the same way of using the...
Yeah, it's the same. You get a command line down here, and Windows, you're going to do dir, right, which happens to work here as well. So you need to make a directory and then put your files in there for this assignment. Each assignment has its own folder. All right, so this is EX5. So let's see if it builds. All right, it builds. And then when you run it, it says all tests passed. Is this? So it looks okay, right? So no problem.
Okay. But,
are you working on 5? So are you working on 5? This one?
No, this is for the previous assignment. This
Okay.
is 5 for this assignment.
So what is your question?
When you did the tests, it said like certain numbers are prime with the command line. I was wondering if I did it wrong.
So I didn't get that.
So I'm wondering what the assert is prime. Like, why did we add that? Like the assert is.
Why is the assert here?
Yes.
Let's suppose that you implemented this incorrectly, like that. Okay. Then you'll get a failed assertion. See? It says is prime 3 equals true, failed. And they go, oh, my is prime function is not implemented correctly. I need to examine the logic in that function and fix the problem. That's the purpose of assert. We'll terminate the problem. At the moment it determines we've got a mistake, terminate, report the line where the problem is detected. Now it's up to the programmer to fix the problem.
Do you want us to put like a sign in this exercise, like
put
add
what?
the number, then see if it's prime or not? A CIN.
No, I have shown you the complete solution, so you don't have to do anything more than what I've demonstrated today. All right. What about the next one? What do we want to do next? Is it 6 that you wanted to look at? It's here, right?
Yeah.
Did you want to look at this one? Yeah. Okay.
Did we do the factoring after?
What?
The factoring after.
What's that?
Number 4 after.
Okay. Hold that. Wait till we're done this, and we'll vote on the next one. Okay. So listing prime numbers. So you previously wrote a console application that computes and displays all the prime numbers inclusively between 2 and a number entered by the user. And that was exercise 3. And you did that? Okay. Now what we want to do is write a program that has the same inputs and outputs as this previous exercise, but this time use the isPrime function you developed in the previous problem to simplify your code. Specifically, replace the inner loop by a call to isPrime so that your new program uses a single loop inside the main function rather than a loop nested within another loop. So let's do it the exercise 3-way first so we know what we're talking about here, right? And then we'll convert it to this better organized format, all right? So let's look at that. Going to start from scratch. So we prompt the user for a number. Is that right? Number 3? Listing prime numbers. Write a console program that reads a positive integer entered by the user. The program computes and displays all the prime numbers between 2 and the number entered. To solve this problem, you need to nest an inner loop within an outer loop. Develop test cases, include them in a multi-line comment. All right, so we'll have test cases. So it'll be, let's do the test cases. And maybe I'll use tap there. So we'll input, say, the number n, and then we have the result. Let's see if that looks all right. Just trying to make this look good here. I'm going to use spaces and not tabs. So if n is 2, the result is just 2. And if n is 4, the result is 2 and 3. 9, the result is 2, 3, 5, 7. Am I doing that right? All prime numbers list all prime numbers between 2 and the number entered. So this is the number entered, n. And 27, or 23, say. It'll be 2, 3, 5, 7, 11, 13, 17, 19, 23. So there we have 4 test cases displayed in a comment, multi-line comment. A multi-line comment, it starts with a slash asterisk and ends with an asterisk slash. Everything in between those two symbol pairs is ignored by the compiler. It's just for humans to read, for documentation purposes. All right, so let's prompt the user. Enter a number. And let's read in the number. So we'll declare the number n, then we use cin with the input operator and read a value in for n. And then we'll print something like, I'm not going to put anything in there yet. Let's see if that works. Enter a number, 4. Okay, so get that part running. All right, so we need a loop here. And we want to print all the prime numbers between 2, so we're going to start the loop at 2, up to and including the number entered by the user. So we need to do less than or equal to n. So I is the variable in the loop that ranges from 2 to n. Oh, yeah, I forgot that. Yeah, that's good, thank you. So, you know, if n is prime, then print n. That's what we got to do, right? Well, how do we decide if n is prime? Well, we got to try to divide all the numbers from 2 to n minus 1 into n. So we need a loop within a loop, like the exercise hinted. We need a loop within a loop. So let's try, we could use j, but j and I look very similar, right? So I'll use k, where k equals 2, k less than n, strictly. No, not less than n. We want to know if I is prime. So in k to be less than I. And if I mod k is 0, that means k evenly divides I, then I is not prime. And so don't print it. And we finish the loop here. Oh. What is the word? If I is prime, then print I. Now see, we got a problem here because it's only at this one point here that we decide it's not prime. And if it's not prime, we want to break out of this loop. There's no reason to stay in the loop anymore. We don't want to print anything. And we want to continue with the next I up here. So we need a Boolean variable to handle this. And I'll call this, Boolean variable is prime, like that. And I'll set it to true. We're going to assume that that I is prime. And that once we find a k that divides into I, then we know that I is not prime. So if I is not prime, then we're going to make a record of that by changing the value of that Boolean variable to false. And we can also break from the loop as well. Now that means break from the nearest loop. So that means we're going to break from that for loop right there. We won't break from the outer loop, just break from this inner loop. So when we break from the inner loop, execution goes to there. So we can check if is prime remain true, we set it to true here. If is prime remain true, then we're going to see out k. I want to put a space after there too, by the way. Otherwise, we don't do anything. Just don't do anything. So we go to the next I. No, it should be is prime, not prime. See, if we find a divisor k, we set is prime to false there. That means when we get to this statement, we won't print k. Now, the code is hard to read. Oh, look at this. Even my comment is wrong. If I is prime, then print I. My comment was bad. If I is prime, then print I. So we're going to assume, but this comment here is so close to the code. I'm going, is prime equal true? I mean, obviously I'm assuming that, oh, but I'm missing the information. I is prime. So let's change the name of that. I underscore is prime. I is prime. We're going to set that to true. Maybe that's easier to read. Maybe it's better self-documenting code, perhaps. So we want to know if I is prime. So we'll just give that variable name, I is prime. So we assume I is prime to be true here. If we find a divisor k for I, then we change our assumption to false by setting a Boolean variable I is prime to false. And then we break from the loop. And of course, then we're going to execute this statement, but the condition is false, so we don't print k. And you know what? It's not k that we need to print, is it? There's a bug. It's I. We want to know if I is prime. If I is prime, we print I. See, what I'm doing here is called refactoring. Did you see how I put the pseudocode in there, I put some English statements in there, and I'm going through the code again, I'm reasoning about it, I'm improving the names to make it more clear, so the logic is more clear. And I'm going through the logic over and over again, and I'm finding bugs. I go, oh, I'm printing K here, I'm supposed to print I here. So then I go back up here and I reason again, and look through it, clean some more. That's the process. It's like you're playing golf, right? And it's almost never you get a hole in one. You don't just hit the ball and go in the hole. And when you're coding, it's just like that. You just get closer to the destination, one step at a time, but you keep working on it. All right, so I believe this will do it. Now we do have some test cases to check here, all right? 2, 4, 9, and 23. Let's see if they work. 2, it prints 2. Oh, look, it prints 2 and then the prompt right away. So I want to put a new line in there. Let's do that. And I'll put it after this outer loop. So I'm going to print it after everything else is printed. All right, so let's check that. 2. Yeah, that looks good. Now I can read that more easily. So let's try the other test cases. Let's try 4. It prints 2 and 3. That's what we predicted. We got it. And then we have 9. It's not a matter of predicting. That's what we plan. That's what we need to have. That's what we expect to have. 2, 3, 5, and 7. Let's try 23. 2, 3, 5, 7, 11, 13, 17, 19, and 23. So we got it. We tried all the test cases that we have in there. All right, that completes this exercise 3. Now exercise 6, listing prime numbers of functions. Let's make this code more readable by using a function. Like this is hard to read because of the nested loop. See, you've got a loop inside of a loop. And you saw when I was entering in this code, I was getting confused between I, K, and maybe even N, right? What's the difference between? Well, I was mainly confused between I and K. But if we break out this code into a function, we won't have that problem to deal with. We won't have this I and K interfering with each other. Sorry about that. I've got to get that. There we go. So how do we do that? All right, so let's define this function. Is prime. I'm going to write it like this time. So the function takes an integer n and returns the Boolean value, true or false. If n is prime, I'm going to return true. N is not prime, I'll return false. So the logic is basically right in here. I cut it and stick it in there. And if you look here, if I is prime, then print I. So it'll be like this. Watch. If is prime I, then, I'm sorry. If I is prime, then C out I. Isn't that a lot easier to look at? In the main, all right, we input an n, and we go through a loop. It starts at 2 and goes up to n, and for each of those values, we pass it to this is prime function. Is prime tells us yes or no, whether it's prime or not. And if it returns yes, if it returns true, then we print I. And if it doesn't return true, we don't print anything. See how main has become simpler to look at? It's the benefit of functions. You don't need functions. Functions aren't required. All computing problems can be solved without the use of functions. They just help with readability. They help make the code easier to reason about. Breaking chunks of logic and separating it off to be like separate things. So we just have to make sure that is prime does what we want it to do. So here, if we determine is prime here, so this is the point in the code where we know that the value is prime. Is not prime, sorry. At this point, we have a divisor. So this is where we can just get right out of the function. We can just return false. We don't even have to break anymore. Just return false. And now the value being passed in is n. So we want to know if n is prime. So it's not I anymore. We're dividing n by k. See? And this would have to be n here as well. So we're changing the variable. And we don't need this Boolean anymore because we just return false on the spot. And if we complete the loop without returning, then we know that n must be prime, so we return true. Look at how simple this code is. Isn't this great? Look at this. Look at how simple, and I can even put that on one line because it's so small. And you know what? I don't like k anymore. I want to go back to I because we're not even using k in the program anymore. I'm going to use I because that's what I'm used to using. And this makes it more readable for me. Look at how nice that, look at that tiny little code right there. You know, you can reason about this code. This code returns false when you find a divisor for n. That's what we want, right? We want to return false. If you find a divisor for n, that means n is not prime. So returning false, n is not prime. And if you complete the loop and you never return false, that means you looked at every possible divisor. You didn't find one. So you can return true, n must be prime. So this is easier to reason about. And this is a unit of logic right here. It's the is prime function. And now we use that inside main. Do you see how much more readable this code is? It's much easier to think about, reason about. Any questions on this one? Looks useful, right? Functions? Yeah. There was a time when functions didn't exist. Programmers programmed computers without functions. They had loops. They always had loops. What's that?
Can you go back? Take a picture.
Go back, let you take a picture? You're not just going to copy this in there, are you?
No.
All right. You got to think through this. Yeah. You got to practice this.
I didn't get all the bottom.
Huh?
I didn't get all the bottom written out. Can I see the?
You got to think it through. You know, I'm trying to. I hope you're like sort of getting the concepts I'm conveying rather than just recording the keystrokes I'm making. You know, that's just a concern I have. I know it's hard this is hard, right? I make it sound so simple. This is so easy. But it's kind of it's something that is not really covered in school anymore. I mean, when I was, in middle school, I started learning how to program. That's because that's what they used to teach. It's a public school. They don't teach it anymore. They don't even teach it in high school. Well, some high schools do. So for some reason, computers these days are like so important and pervasive that they don't teach programming to children anymore, but they used to when computers were just starting out. So that's why it's harder to understand this material now. But when you run into an old person like me who's been programming since middle school, then it feels like breathing to me. This is like breathing. And for you, it's like a barrier that you got to overcome. But eventually, it can become like breathing to you as well. But you have to practice. All right, what do you want to do next? Go home? Yeah.
I'm running mine and it's only spitting out the first prime number.
Say it again?
I'm running mine and it's only spitting out the first prime number.
You want to take a look at yours? You want to take a look at yours? Dashboard. This is great, and we have this thing. We can just do this. Let's do some debugging. Let's see, give me a few letters.
J-M-E-Y.
That one?
Yeah.
Okay. Nice and clean. One tab is open here, one tab down there, and that's very nice to see that. All right, so this is what you're doing right here. You enter a positive number 8, and it prints 2. All right. I'm going to drop this down a little bit. Does that drop on your screen when I do that?
No.
It doesn't, okay. I was wondering how this thing works. All right, so why is it only print 1?
He's doing I mod I.
What's that again?
In his function on top, he's doing I mod I.
I mod I. Look at that. I mod I. Well, so I'm going to say this line is not indented correctly, line 10. Fix the indentation in line 10. Fix the indentation in line 11. Yeah, 12 is not indented correctly either. Yeah, good. Yeah, fix that up. Keep fixing that indentation. Now, see, you've got 2 tabs here. You don't need 2 tabs there, just 1 tab. Go ahead and clean it up from, there you go. Now, the if statement is inside of the for loop, so we indent once. Now, the return statement is inside the if statement. Whoa, 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 whoa. Line 10, the return statement is a child of the if statement. You have to show that parent-child relationship with an indent. That's it, you got it. Oh, wait a minute. Now, this brace here, is that meant to close the if statement, or is that meant to close the for statement?
That's supposed to be closing the if statement.
The if statement. Well, then you're missing an opening brace right there. See, when you clean up the indents, it'll help you catch logic errors. It's very important to do cleaning. When you do cleaning, you catch logic errors. You get the reason, you repeat the reason that you have about your code and maybe make adjustments to it. Now this line 12, like, I'm just a stickler here. This is not, where is this supposed to happen? Is that supposed to happen inside the for loop, which means it's indented? Or is it outside the for loop? You want that outside the for loop. Where do you close the for loop? Where's the closing brace? There is no closing brace for the for loop. Yeah, you need to include a closing brace for the for loop. Well, I thought you said return was on the outside of the for loop.
It is.
Okay, then the closing brace for the for loop must not include the return true statement. Like this is the opening brace of your for loop right there. You've got to put in a closing brace for the for loop.
Is it this one here?
That closes your if. You told me that's what you were going to use to close your if statement.
Put another one.
There you go. You see that? You see that how we were dealing with indentation? And we got bugs. You had bugs in there. And they're gone. All right, let's try it. Let me see. Can I see if you type in here, do we see it? We do. Look at that. Works. Oh, it doesn't work. It prints 9. 9 is not prime. What's the problem? 4 is not prime. 6 is not prime. 8 is not prime. What's the problem? Who can see the problem? I can see it. All right.
Less than or
Huh?
equal to? Is it I less than or equal to?
I less than or equal to n? That? No, I starts at 2 and goes up to n minus 1. Nobody sees the problem? No. We have I strictly less than n. That means the last value of I we use is n minus 1. So that's good. What's the logic error there? Someone's got to be able to see. Yeah, back there.
Should it be n mod I?
Exactly. Yeah, we just had that reversed. All right, let's try that. Try 9 again, right? That looks good. Let's try the other. Oh, you don't have the test cases in as a multi-line comment yet, right? So I'll have to add that in there. You can do that later by yourself. So that's good. That's it, the debugging session there. And we have 9 minutes. Anybody want to do something in 9 minutes? Yeah.
Could you go back to 6 where you did the shortcuts from?
Go back to 6. Here?
Where I want to see how you did the shortcuts, like how you changed the codes and did the shortcuts of this prime.
The shortcuts. I don't know what do you mean by shortcut?
So for exercise 6, you did the same thing for exercise 3, but changed to its prime as a shortcut.
Yeah, so we have a function here, so we don't have a nested loop anymore. We call the function has the inner loop in it. So we don't have a loop within a loop anymore. And we don't need to hang on to a Boolean variable anymore. We can just return false, return true straight away like that without having this extra variable. See, I could have left the Boolean variable in there. It would just be more code to look at and read. If we could take it out, just take it out. And that's it, right? This is not bad. Let's take just quickly before we break here. This is going to be done. And then you've got the arrays assignment. And it's going to be like this for a lot of the course now, just implementing functions. So I ask you to implement a function that does something. And then you write test code for it. All right? Okay. I think that's enough for today, right? That's it. Okay, that's good.